Welcome to AERO 2230 ProPilot 1, presentation number 15 on VORs, Very High Frequency Omnidirectional Range. A VOR is a radio navigation station that transmits signals that represent 360-degree radials from the station. Two very high frequency signals are transmitted that represent each of the 360-degree radials. Each of these very high frequency signals is a different phase. There's a reference phase and then there's a variable phase. The VOR receiver in the airplane receives these different phases and interprets them as one of the 360-degree radials emanating from the station. Here's an illustration of a VOR that is oriented to magnetic north, and each one of the 360-degree radials emanating out from the station. You may have seen one of these VORs at a local airport. It's one of the oldest forms of radio navigation still in operation. VORs have been around for over 50 years. There are two antennas mounted on the vertical stabilizer on either side in what looks like a V. These are the antennas for the VOR in the aircraft. Here's a picture of the VOR instrument in the aircraft. The VOR includes an OBS or an omni-bearing selector in the lower left-hand corner, and this OBS is twisted to turn the OBS card, course card, to select the course index. That's how you select the course that you want to follow either to or from the station. The CDI or course deviation indicator is the needle in the center, and that CDI moves either left or right depending on where you're located from the course that you've selected. These dots on either side of the center are called deviation scales, and the CDI moves either left or right. You can tell how far away you are from the selected course by looking at the number of dots. These two triangles are known as to and from indicators, and there's also an off indicator or an off flag which indicates that you're not receiving a good signal. Most textbooks will tell you the to and from indicators will tell you whether you are going to or from the VOR station that you've selected. But that can be a little confusing. If you look at this airplane on the left, it's on the 015 radial, and that's exactly what this VOR is indicating. This aircraft is on the 015 radial. But you can see, even though this aircraft is in different positions, this one is traveling from the station, but this one is traveling to the station. Even though it is traveling to the station, the VOR will still say from, because the aircraft is on the 015 radial. A better way to think of the to and the from indicator is that it tells you which radial you're located on. If you have a from indication, then you are on the radial that you have dialed under the course index. You're on the 015 radial. It doesn't matter whether you're flying to or from the station, as indicated by this aircraft. If you have the 015 radial dialed in, and you have a centered needle with a from indication, that means you are on the 015 radial. If you had a to indication, then that means you're on the reciprocal radial, pointed at by the tail of the CDI, and that would be the 195 radial. So that would mean that you were down here, and that you were flying to the 015 radial. So think of that in those terms, and you'll avoid a lot of confusion. The CDI, or the course deviation indicator, moves left or right, depending on where your aircraft is located relative to the radial that you've dialed into the VOR. Each one of these dots to the left and right of the center of the VOR represents 2 degrees deviation from the course. So if the needle moves to the right, and let's just say, for example, it's 2 dots off to the right, that means that you are 4 degrees left of the course. Think of that CDI, course deviation indicator, as your highway in the sky. If it's off to the right, that means you have to fly toward it. So you fly to the needle. So if you're 4 degrees off to the left of the course, you would turn right until the needle came back to the center. Then you're back on the highway. A full-scale deflection either to the left or the right of the center of the VOR represents a 10-degree deviation from the course. So if the needle is deviated to the right all the way to the last dot, that means you're not on the 070 radial. That means that you are on the 060 radial. Here you see 4 airplanes with a VOR that's been dialed to the 070 radial. The CDI is off to the right, and it indicates that the airplanes are displaced 6 degrees to the left of the 070 radial. So all of these airplanes, even though they're flying in different directions, are on the 064 radial. Here you see an HSI, or horizontal situation indicator, with an RMI, or a radiomagnetic indicator, superimposed on the CDI. The difference between the CDI on the traditional VOR instrument and the HSI is that the RMI always points to the station. When you turn the OBS on the lower left-hand side of the HSI, you're actually twisting the RMI. And if you twist the RMI until you get a centered needle with the arrow at the top, that means that you're on the radial indicated by the tail of the needle, and you're going to the radial that is dialed into the top of the HSI. Now the CDI in the center of the HSI works just like the CDI on the VOR. If you see that needle move to the right, that means the course that you've set is to the right, and you're off to the left. The airplane in the center of the HSI makes that a little easier to visualize, because you can see that your highway, or your course, is off to the right, and you need to turn to the right in order to re-intercept the course. Here's another HSI that has a to from indicator, and it's indicating to. The pilot has the 200 radial dialed in on the OBS, so this means that the aircraft is actually on the reciprocal of the 200 radial, or on the 020 radial. So this aircraft is flying on the 020 radial toward the 200 radial. Notice that this HSI also has a glide slope indicator, which means that this is equipped to track a localizer on an ILS, instrument landing system. The localizer is just like a VOR. You track using the CDI, left and right, and the glide slope tells you whether you're on, above, or below the glide slope. If this needle is at the top above the center, then that means you're below the glide slope, and you would decrease your descent rate until the needle came back to the center. If the needle were below the center, then that means you're above the glide slope, so you would increase your descent rate until that needle came back to the center, and that would indicate that you're right on the glide slope down to the runway. It's important to remember that the VOR is also a VHF radio using very high frequency signals. Just like the radio in your aircraft, the VOR may not be able to receive the signals if there's any obstacles or terrain between you and the station. You can identify a VOR on a sectional by looking for compass rose. Compass rose is always pictured around a VOR. The identifying information is in a box located close to the VOR. In this case, this is the Greene County VOR, and the frequency to dial into your navigation radio is 115.7 to receive the signal. Notice that the designator for this VOR is GCV, Golf Charlie Victor, and that there is Morse code next to GCV. Morse code is broadcast over the VOR frequency so that you can turn up the volume on your navigation radio and listen to the Morse code to positively identify that you're listening to Golf Charlie Victor. Notice that the meridian or the longitude line next to the VOR, which points true north, does not agree with the north indication on the VOR. That's because the VOR is oriented to magnetic north. So again, the HSI makes it easy to intercept and track a course to a VOR. This airplane has the 040 radial dialed in, and notice that the needle is off to the left. So the aircraft will fly to the left until the needle centers, and at that point the aircraft can then turn to the right and track the radial to the VOR. In this case, the aircraft is on the 220 radial. When you get your instrument rating, you'll learn that the VOR is required to be checked every 30 days. And there should be a log in the aircraft indicating the last date that it was checked. If it was more than 30 days, the VOR is no longer legal for IFR flight. There are a few different ways that you can use a VOR to locate your exact position on a sectional. On the left side, you have an airplane using two VORs. One VOR is dialed until the needle centers with a from indication, and the second VOR is also dialed until the needle centers with a from indication. And then the pilot can then draw a line on each radial from the VOR, and where those lines intersect is where that aircraft is located on the sectional. The aircraft in the center is tracking what's called a DME arc around the VOR. This aircraft is equipped with DME or distance measuring equipment, so it can track an arc around the VOR, maintaining that distance all the way around. The aircraft on the right is using a VOR and a non-directional beacon to locate its exact position on the sectional. Again, the VOR is dialed in and the OBS is twisted until the needle centers with a from indication to give the pilot the exact radial from that VOR. The pilot can then dial in the NDB, non-directional beacon, on an ADF instrument in the aircraft to get the bearing to the station. And where that bearing to the station crosses the VOR radial is the exact location of the aircraft. This aircraft is again using two VORs to get a fix on its position. VOR A with a frequency of 115.2 is dialed into the first VOR, and the OBS is twisted until the needle CDI is centered with a 2 indication. That tells the pilot that this aircraft is on the 314 radial going to the 134 radial. The second VOR is dialed to VOR B with a frequency of 113.8, and the OBS is twisted until the needle centers with a from indication. That tells the pilot that the aircraft is on the 220 radial from VOR B. Where those two radials cross is the exact position of that aircraft on the sectional. It's important to remember, if you are flying to a VOR, as in this illustration, once you get close to the VOR, in what's called the zone of confusion, the CDI is going to start getting agitated and moving left and right. And it's important to remember that that just means that you're getting close to the VOR. So maintain your course And once the aircraft passes over the VOR, the to from indicator will go from a to a from indication, which is your signal that you have passed the VOR. And eventually, the needle will settle down. You can locate your position from a VOR without twisting the CDI by looking at the location of the CDI and the to from indicator. The VOR OBS is twisted to the 340 radial, but the needle is off to the left. So that just means that the aircraft is to the right of the 340 radial, as indicated on the left here. The to and from indicator is indicating from, which means that the aircraft is on the side of the 340 radial. So the aircraft is located here on the right side. So if you divide that up into quadrants, that tells you that the aircraft is located in the upper right-hand quadrant from the VOR. This aircraft is located to the left of the 085 radial and also on the reciprocal side from the 085 radial, so it's located over the 265 radial. You may hear the CDI referred to as a command instrument. That's because you're supposed to follow its commands if you're using it to track a radial. So, as in this illustration, if the needle is off to the right, then you are left of course. You need to fly to the right until you intercept the course. Once the needle is centered, then you can turn toward the course and track it. It's important to remember the wind when you're tracking a radial to a VOR. In this case, the aircraft is tracking the 360 radial, but because of the wind from the right, it's maintaining a heading, a magnetic heading of 352. That will keep it on the course on the 360 radial all the way to the VOR. If an aircraft is equipped with DME, distance measuring equipment, radio, the radio actually sends out a signal to the station, which is bounced back to the radio. And the time that it takes for that signal to return to the radio is then converted into a distance. It's important to remember that DME radios measured slant distance, not ground distance. That means that the distance measured by a DME radio is actually a little bit more than the ground distance to the station. It also means that when the aircraft is right over the station, it will measure the distance from the station up to the aircraft. So in this case, the aircraft that is at 9,000 feet above ground level will show a DME of 1.5 nautical miles. Here's the panel to a DME radio showing the distance to the station of 119.9 nautical miles. Remember, that's slant distance. It also shows the ground speed of 120 knots, and time to the station is shown as 58 minutes. Well, that's the end of presentation 15 on VOR navigation and the last presentation for the course. Make sure that you've completed all of the quizzes and submitted review questions for Test 3 to the Dropbox. Test 3 will be on the last day of class.